Today we're talking about solving trig equations algebraically. So the other day we talked about how to graphically solve trig equations. Now we're going to look at the algebra for them. So of course we know how to solve a trig equation if it's a value on our unit circle. So this table is really going to help us for when it's not something on our unit circle. However, I'm going to use values from our unit circle that we're used to in order to help us figure out why it's working. So let's say that this first column knows it says solve each equation for x. So we're going to say that c is some number. So the first part, notice possible values of c, I'm going to use in between -1 and 1. So let's say that the sine of c is equal to 1/2, or not c, sorry, the sine of x is equal to 1/2 because we're solving for x. So in this case, c would be 1/2. So if we look at it graphically, this would be the line y equals 1/2, let's say. So we know that it's going to hit here and here in my graph. So we know that we have two solutions from 0 to 2 pi for x. Even if we look at our unit circle, we know the same thing. Where does the sine equal 1/2? It is equal to 1/2 here at pi over 6 and over here at 5 pi over 6. So those give us both of our solutions. So algebraically, how would we find this, especially if it's not something that is on our unit circle? So in order to get x out of the sine, remember that we use our sine inverse to do that. So x is equal to solve for the angle, so the sine inverse of 1/2. And then, of course, we have to add all of our coterminal answers if it's not just asking for values between 0 and 2 pi, so plus 2 pi n. So that would give me my first solution of, so the sine inverse of 1/2 is equal to pi over 6. So x equals pi over 6 plus 2 pi n. So our first solution, I'm just going to call this x sub 1, is equal to the sine inverse of, in this case, we're just going to do in general, of c plus 2 pi n. That would give me my first solution. So the question is then, how do I get my second solution, which is 5 pi over 6? So this right here is an identity that we didn't actually talk about, but sine of x is equal to the sine of pi minus x. This gives us the same values on our unit circle. So if I were to look at pi over 6, if I do pi minus pi over 6, get a common denominator, which means I would multiply this by 6 over 6 for the common denominator. So 6 pi over 6 minus pi over 6, notice that gives me 5 pi over 6 because it's an identity. So to get the second solution, we can actually do x is equal to pi minus the sine inverse of 1/2 plus 2 pi n, because that's all our coterminal answers. So in this case, we get x is equal to pi, and then we said the sine inverse of 1/2 was pi over 6. So pi minus pi over 6 plus 2 pi n, and we just said that that's equal to 5 pi over 6 plus 2 pi n. So that gives me my second solution. So for x sub 2, pi minus the sine inverse of those value, whatever the value of c is, plus 2 pi n gives us all of the solutions. So the next possible values of c, we're saying when c is equal to 1. So let's say we have the sine of some angle is equal to 1. Well, we know graphically that there's only one place that we're going to hit where the sine of x is equal to 1. Even if we look at our unit circle, there's only one angle measure that gives us 1 on our unit circle. So we can just go ahead and use our unit circle to answer this. We know that since there's only one answer, when your c value is equal to 1, then x is equal to, using your unit circle, pi over 2 plus all coterminal answers, 2 pi n. So the same thing for when x is equal to negative, or sorry, not x, but c is equal to -1. So if we have the sine of x equals -1, we hit in one spot on our unit circle and one spot on our graph, which would be down here. So that would be 3 pi over 2. But remember, whenever we're doing sine inverses to solve, normally we said -pi over 2. So I'm just going to go ahead and use that. Could you write x equals 3 pi over 2? Sure. So you could either say -pi over 2 plus 2 pi n, Or of course you could write x equals 3 pi over 2 plus 2 pi n. But since we're talking about using sine inverses to solve, because here in order to get x by itself, you would do the sine inverse of -1. So to do the sine inverse, we know that the solutions are in the first quadrant and the fourth quadrant. So that's why I'm using negative pi over 2, because it's from negative pi over 2 to pi over 2, which we talked about in the other section. So when your values are above 1 or below -1, remember that we don't have y values above 1 or below -1. So for this last section, this would be no solutions. So for example, if I had the sine of x is equal to 3, and I try to do the sine inverse to solve, I know that this would never work because we don't have values above 1 or below -1 on our unit circle. So that means this is no solution. So let's go down to the bottom and actually look at an example. So for an example of sine, we have the sine of x is equal to -0.75. So of course this is not on our unit circle, which is why we're learning these rules in order to help us find our values without having to always, graphically look at our solution, which we could still do. So -0.75 would be somewhere down here. So we know we're going to have two solutions. So how do we find our solutions if we're using just the inverse key in our calculator? So to get x by itself, we use the inverse. So our first solution would be x sub 1 is equal to the sine inverse of -0.75, of course, plus all our coterminal answers, 2 pi n. So then all we have to do is plug this into our calculator. So if I'm plugging this in, second sine inverse of -0.75, and I hit enter, and notice we get -0.8481 when we round. So x sub 1 equals -0.8481 plus all our coterminal answers, 2 pi n. So that gives us our first solution. And then for our second solution, we do remember the x minus the sine inverse. So x is equal to, I said pi minus the sine for inverse is what I meant to say. So pi minus the sine inverse of -0.75 plus all coterminal answers. So all we have to do is plug this into our calculator. So pi minus the sine inverse of the -0.75, or we could have used our answer from above, and we get x is equal to 3.9897 plus 2 pi n. So that gives us our second solution. So you might be asking, why this first answer, so these values are not from 0 to 2 pi. So remember, the reason this answer is not from 0 to 2 pi, because when you do the sine inverse, negative answers have to be in quadrant 4, and positive answers would be in quadrant 1 for the sine inverse using your calculator. And so and the values are in between -pi/2 and pi/2. So that's why it doesn't actually give these 2 points necessarily on our graph. It's giving us, if we were to continue our graph going the other way, we know that this would go down this way. So on our graph, it's actually going to be giving us this solution over here. So if we go to our graphing calculator, just look at this graphically, I have plugged the sine of x plus 0.75 into my calculator. And something I forgot to mention, make sure you're in radian mode, which we are. I changed my window to be from -2 pi to 2 pi. And my y value is from -3 to 3. So if I hit graph, this gives me 2 cycles in my graph. And for this, since I set it equal to 0, I'm looking for the zeros on my graph. So it's going to be different than what this one's looking, because we're not looking at the intersection, as this would be like, look for the intersection right here. So here on our graphing calculator, we would be looking at the zeros. So if I do second trace value, and again, if I just do the sine inverse of -0.75, notice I get -0.848, and if we round 1, so that gives us a solution right here. So that other solution, if I were to take this value that I have, so again, -0.8481, And if I were to add 2 pi to that answer, notice that would give me my other solution, that's the positive solution. So if the question instead was to give the solutions from 0 to 2 pi instead of finding all the solutions, then I would be using this as my answer instead of the negative 0.8481 because that's not in between 0 and 2 pi. So I would have to take, again, that first answer, negative 0.8481, and add the 2 pi to that to get the answer from 0 to 2 pi, which is that 5.4351. And this answer right here, that one's okay because that one, again, is in between 0 and 2 pi. So my solutions from 0 to 2 pi, if it asks us that, because sometimes it'll say find all the solutions, and sometimes it'll say find the solutions from 0 to 2 pi. So if that was the case, we would say 3.9897 and x equals 5.4351. These would be the solutions from 0 to 2 pi, whereas these are all possible solutions. So that's the difference of the questions. All right, so now that we're done with sine, let's go ahead and look at cosine. So for cosine, let's say that we had values in between for c in between -1 and 1 for our trig ratio, and we're solving for, of course, x again. So let's say that we have the equation, the cosine of x, and our c value in this case was equal to, let's do 1/2 again. So if our c value is 1/2, we also know that we have two solutions on our graph. We would be hitting here and here. So that means we're going to have two solutions. And this is on our unit circle as well. So on our unit circle, where do we get 1/2? We get 1/2 here and here. So at pi over 3 and also at 5 pi over 3. So because this is on our unit circle, we can easily use our unit circle. So to find our solution, if we were to do the cosine inverse, so x is equal to the cosine inverse of 1/2 plus all our coterminal angles, 2 pi n, we would get x would be equal to pi over 3 plus 2 pi n. And then that second solution we can see from our unit circle, x is equal to 5 pi over 3 plus 2 pi n. So the question is, when it's not something on our unit circle, how do I get that second solution? So remember our negative angle identity? We had the sine, or not the sine, sorry, the cosine. The cosine of negative x is equal to the cosine of x. So I can actually, instead of to solve this, I could say that x1 would be equal to the cosine inverse of c plus 2 pi n. But notice the negative of that angle also gives me the same answer. So instead of writing pi over 3, we can do the negative angle measure. So if I have pi over 3, that's the same thing as negative pi over 3. Those are coterminal. We're just using the negative. So pi over 3 and negative pi over 3 give us our solution. So instead of saying 5 pi over 3, I could have said x equals plus or minus pi over 3 plus 2 pi n. Those would give me the same solutions. So over here, to write the solutions for cosine, it's easier. You don't have to do pi minus the answer. You can just do x equals plus or minus the cosine inverse of 2 pi n, and those will give you all of your solutions. So x equals plus or minus the cosine inverse. And again, think about this is because cosine, notice that you have the one that's up here and the one in the quadrant 4 with the negative. So again, the positive and the negative because it's a reflection across that x-axis. So for c values that are equal to 1 for cosine, we only have, again, one solution. So on our unit circle, where is the cosine equal to 1? Right here at 0. So we would say x is equal to 0 plus 2 pi n. Do you have to write that 0? No, you could just say x equals 2 pi n, because again, you don't have to write the 0, it's just a placeholder. So where do we get -1 on our unit circle for cosine? Over here at pi. So x is equal to pi plus 2 pi n would give us our solutions. And of course, if c is above 1 or below -1, we would have no solutions. So down here, if I want to solve this, I would say since 0.6 is in between -1 and 1, we know we're going to have two solutions. So x is equal to plus or minus the cosine inverse of 0.6 plus 2 pi n, all our coterminal answers, because we're finding, again, all the possible values of x. So all I have to do is plug this into my calculator. And when I plug this in, we get the cosine inverse of 0.6. So that gives us 0.9273. So x equals plus or minus 0.9273 plus 2 pi n. Those give us all of our solutions. Now, if we only wanted the solutions from 0 to 2 pi, such as down here is asking, then I can't use the negative answer. So x equals -0.9273 wouldn't work because that's not from 0 to 2 pi. So I need to find the coterminal answer by adding that 2 pi to my solution. So if I add that 2 pi to my solution, I would get the answer in between 0 and 2 pi. So that would give me 5.3559. So x equals, and the first answer we got, which is positive, so x equals 0.9273, and x equals 5.3559 would give me my two solutions. We can also confirm this graphically. So if I plug this into my y equals like we did before, and I could look at the graph. So again, if you did second trace value, the cosine inverse we know is the, again, -0.9273 about. So it's not going to give us exactly 0 because we rounded, but so that would be here. So if I take that answer, second trace value again, -0.9273, and add again that 2 pi. That's where we got our solution from 0 to 2 pi, which is the 5.3559. And the other solution was just the positive 0.9273. So that gives us the first answer, and that was the other one. So that would be if it asked you to find the solutions from 0 to 2 pi. If not, if it just asks for all of the solutions, it's a lot easier because you just do plus or minus your answer plus 2 pi n for cosine. And of course, if the value's on the unit circle, it's even easier because you just use your unit circle values. So the last one, of course, that we want to look at is our tangent graph. So remember, the tangent's different because the period of tangent is equal to pi, unlike sine and cosine where you're adding 2 pi. So for these, we know that this is the graph. Look at -pi/2, and this goes to, of course, pi/2. Remember that the value at 1 and -1 is at pi/4, and so -pi/4 and +pi/4. So for this, it's a lot easier because the range of this graph is all real numbers. So since the range of the graph is all real numbers, that means that when you're doing the inverse of this problem to find your solutions, x equals the tangent inverse of that c value plus pi n would give you all of your solutions. Because notice that you're never going to have more than one solution on one wavelength. You only have that one solution, so you don't have multiple things that you need to do. And it doesn't matter what that c value is, because no matter what, since the range of tangents all real numbers, you can take the tangent inverse of any number and it will give you a solution. So down here, if I want to find my solution, x is equal to the tangent inverse of -4 plus pi n, and then of course I can just plug that into my calculator using again, radian mode. So in my calculator, if I do the tangent inverse of -4, that's our solution, plus pi n. So x equals -1.3258 plus plus pi n. And if I just want the answers from 0 to 2 pi, so I know then negative 1.3258 would not work because it's not from 0 to 2 pi, so I need to add pi to that answer. So if I add pi to that answer, I get x equals 1.8158. But since the answers for this are from 0 to 2 pi and the period is pi, that means we would actually have two solutions. It would be a repeated answer, but that's okay. So I would have to add another pi to the solution I just got to get my second answer, which is 4.9574. So this one would give you two solutions from 0 to 2 pi because, again, the period's pi. So again, it would just be a coterminal answer with that adding pi to your answer. So again, we're not adding 2 pi to this one. Remember, we're adding pi because the period of tangent is pi, so that's a little bit different. All right, so let's go ahead and actually solve some examples for this. So we're going to solve these to find all the possible values of x. So we're not going to worry about just 0 to 2 pi for these. So cosine, in order to solve, first you want to isolate your trig function that you're trying to solve for because we need to get x by itself. So if I isolate the cosine of x by adding the 1 dividing by 8, I get cosine of x is equal to 1/8. So then to get x by itself out of the cosine, we do, of course, the cosine inverse. 1/8, of course, is in between -1 and 1. So that means our solutions are going to be, because we're going to use this right here, so our solutions are going to be plus or minus cosine inverse of that plus 2 pi n. So x is equal to plus or minus the cosine inverse of 1/8 plus 2 pi n gives us all of our solutions. And if you plug that into your calculator, you get 1.4455 plus 2 pi n. So looking at the next one, this is something on our unit circle, so we could use our unit circle values to write our solution, but let's go ahead and practice using our table. So root 2 over 2 we know is in between -1 and 1. So we're going to use these solutions, sine inverse plus 2 pi n and pi minus the sine inverse plus 2 pi n. So we know x1 equals the sine inverse of root 2 over 2 plus 2 pi n. And again, we know that is on our unit circle, be right here on our unit circle. So that gives us pi over 4. So our first answer is equal to pi over 4 plus 2 pi n. And we know those values because we did our inverses in the last topic that we talked about. So for this, to find the second solution is x sub 2 is equal to pi minus the sine inverse of root 2 over 2 plus 2 pi n. And what's the sine inverse? We just said pi over 4. So x sub 2 is equal to pi minus pi over 4 plus 2 pi n. So we need to get a common denominator. This you have to multiply by 4 over 4 to get that common denominator. So 4 over 4, so 4 pi over 4 minus pi over 4 is 3 pi over 4. So x sub 2 equals 3 pi over 4 plus 2 pi n. And again, this one you didn't really have to do that step because you could have just used your unit circle. You know that we get root 2 over 2 here and here on our unit circle. So that would have been fine, but we're just practicing the steps so you can see how and why they work. So the next one is slightly different. Notice that now I have changed the angle to be a double angle. And so since this is a double angle, it's a little slightly different to solve. So we can't just use our unit circle values because it's 2 times that angle. So if I solve this one using our rule, we get x is equal to plus or minus the cosine inverse of root 2 over 2 plus 2 pi n, but it's not just x here, it was 2x. So I actually have to write 2x is equal to plus or minus the cosine inverse of root 2 over 2 plus 2 pi n. And again, since it's on our unit circle, anytime something's on your unit circle, you always want to use your unit circle values to find the exact answer. If it's not in your unit circle, use your calculator. So in this case, we know that this is on our unit circle. Again, it's right here. So we know now we're using the cosine of that, which of course is pi over 4, just like the last answer. So here we get 2x is equal to plus or minus pi over 4 plus 2 pi n, and then you're not done because you have to solve for x. So if I'm solving for x, that means I'm going to be dividing every term by 2. So when I divide by 2, it's the same thing as multiplying by 1/2. So if it helps you instead to write pi over 4 times 1/2, that's the same thing. And right here, 2 divided by 2 gives us just pi n. So pi over 4 times 1/2, or pi over 4 divided by 2, is going to be pi over 8. So x equals plus or minus pi over 8 plus pi n. And you can kind of check to see your work, because remember, we talked about finding the period of our sine and cosine functions. And here, if your b value is equal to 2, let's get rid of that. So if our b value equals 2, remember that b times the period equals 2 pi. So if our b value is 2, we get 2 times the period equals 2 pi. So the period is equal to 2 pi divided by 2, which is pi. So that makes sense that our answer that we get is plus or minus pi over 8 plus pi n. So those would give us our two solutions. Now, would it be incorrect if you would have just used the 7 pi over 4, which is, of course, in quadrant 4 in your unit circle? That would have been fine as well, but you still have to divide each of those values by 2. So if you didn't, again, use that negative pi over 4, that would have been fine. So had we had done that and said 2x equals pi over 4 plus 2 pi n, or you could have written 2x is equal to 7 pi over 4 plus 2 pi n. You still get your same solutions, it's just a different way of writing it. So here, again, pi over 8 plus pi n, and then you would have still had to divide these by 2, and you would have gotten x is equal to 7 pi over 8 plus pi n. So using this as our solution from your unit circle is fine. Or again, like I said, it's a lot easier just to put plus or minus in front, and that would give us this solution here. So those are the same solutions. It's just, again, a different way of writing it. Either way, it's fine as long as it's not asking you to find the solutions from 0 to 2 pi. So for the next one, we'll do the same thing. So now we have the sine of 4 times the angle equals root 3 over 2. So if I want to solve this one, remember we would do our first answer would be the sine inverse. So to get this out of the sine, I have to take the sine inverse. So 4x equals the sine inverse of root 3 over 2 plus 2 pi n. And so if we keep going, we have 4x is equal to, and you can think about your unit circle, where is the sine equal to root 3 over 2? We know that it's going to be up here at pi over 3. So pi over 3 plus 2 pi n, that's going to give us our first answer. So if we get rid of that 4, we can multiply everything by 1/4 or divide everything by 4. It's the same thing. So 4 times 1/4 gives us x equals 1/4 times pi over 3 is pi over 12. Plus, and then this would give us 2 divided by 4 is 1/2, so pi over 2 times n. So this would be my first solution. And of course, we're not done because we need to find our second solution. So 4 sub x of 2 would be equal to pi minus the sine inverse of root 3 over 2 plus 2 pi n. Now that gives us 4x is equal to pi minus the sine inverse. Remember we said was pi over 3. Don't use pi over 12 because, again, remember the formula is sine inverse of that first one, and pi over 12 is not the sine inverse of root 3 over 2. It's the answer to our first part of our equation. So pi minus pi over 3 plus 2 pi n. So then when we solve, we get 4x is equal to, here we have to get a common denominator, so multiply this by 3 over 3. So 3 pi over 3 minus pi over 3 gives me 2 pi over 3. So 2 pi over 3 plus 2 pi n, and then of course we're multiplying everything by 1/4 to get our solution. So I'm going to write it over here. So x is equal to 2 pi over 3 times 1/4. Notice that this would give us 2, so that would be pi over 6 for our solution. So pi over 6 plus, and then again we have 1/4 times 2 pi n, which gives us pi over 2 times n. So this is our second solution here. And we can kind of check to make sure that makes sense. So here your b value is equal to 4. So 4 times the period equals 2 pi. So the period would be equal to 2 pi divided by 4, which is pi over 2. So that makes sense that this is pi over 2 times n. And of course, you could always plug this into your graphing calculator to check as well. And of course, they're going to get a little bit more complicated than the ones we just used. So let's look at something like this. For this kind of problem, if it helps to use substitution, we can. So I'm going to let the sine of x equal some variable. Let's just say u for this case. So if I take out the sine of x, so to get sine squared, remember that's the sine of x times the sine of x, which gives us the sine squared of x. So this is really u squared. So we would have 3u squared minus u minus 2 is equal to 0. So notice this is a quadratic equation. So to solve quadratic equations, we could use the quadratic formula, or we can factor to solve. So for this one, you can factor. So this factors into 3u plus 2 times u minus 1. And so if we're going to go ahead and solve for u, we would set each of these equal to 0 to solve. So 3u plus 2 equals 0, u minus 1 equals 0. So here we get u is equal to negative 2/3, because subtract the 2 divided by 3. And over here we get u is equal to 1. So before, remember we said let u equal the sine of x. So this is not our answer, because remember that u is really the sine of x. So we have the sine of x is equal to negative 2/3, and the sine of x is equal to 1. So now I have to solve these two equations. So remember that when the sine of x is 1, that's easy because we only have one solution on our unit circle. So since it's on our unit circle, we're going to use our unit circle value. So for this one, we know x is equal to pi over 2 plus 2 pi n, because it only hits one time for 1. So then for this one, because this is in between negative 1 and 1, we have two solutions. So to find our solutions, we're going to use our chart to help us. So x is equal to the sine inverse of negative 2/3 plus 2 pi n. And remember, the second solution would be x sub 2 is equal to pi minus the sine inverse of negative 2/3 plus 2 pi n. So because this is not on our unit circle, we're going to just plug this into our calculator. So if you plug this into your calculator, we have the sine inverse of negative 2/3. Again, make sure you're in radian mode. And when you do that, you get this solution, negative 0.7297. So x1 is equal to negative 0.7297 plus 2 pi n. So that gives us our first solution. And so our second solution, x sub 2, is pi minus the sine inverse. So on my calculator, I'm just going to hit pi minus the sine inverse. This was the sine inverse. I'm just going to hit that and enter. So that gives me x sub 2 is equal to 3.8713 plus 2 pi n. So that gives us our second answer. So again, we did pi minus the sign inverse to get that second solution. So that means that this problem has three answers, the pi over 2 plus 2 pi n and the 2 that we just found. So I'm going to skip 6 and let's do number 7. So same thing, I'm going to let, because I see quadratic term, a linear term, and a constant term. So I'm going to let the cosine of x equal some variable, we'll call it u in this case. So 2u squared minus 5u plus 2 equals 0. So for this one, I would want to look for try to see if I can factor it. So if I cannot factor this, then I can use quadratic formula. So let's say that, pretend like we can't factor this, and let's go ahead and use a quadratic formula just to remind ourselves that we can use a quadratic formula and what the quadratic formula is. So x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So if we don't remember how to factor, we can always use our quadratic formula, which we could have done on the last problem as well. So here, when I go ahead and solve this, this is my a, this is my b, and this is my c. So that means we get x is equal to negative 5 becomes 5 plus or minus the square root of negative 5 squared minus 4 times 2 all over 2 times a, which is 2 times 2. So x is equal to 5 plus or minus. And then underneath of here, we have negative 5 squared, remember, is 25 minus 4 times 2 times 2. So when we simplify, we get plus or minus the square root of 9 all over 4. The square root of 9 is 3, so we get, and I should be using u instead of x because we used u as our variable here. So u is equal to, sorry about that. So u is equal to negative 5 plus, and the square root of 9 is 3, so negative 5 plus 3 over 4, and u is equal to negative 5 minus 3 over 4. So when I solve, we have our two solutions. Sorry, that's not, I forgot that was negative 5, so that's just 5 plus or minus the square root. I don't know why I wrote that negative there. So when we solve, we get 5 plus 3, so 8 divided by 4, which is 2. And down here, we would get negative 2 over 4, which is, or sorry, positive 2 over 4, which is 1/2. So 2 and 1/2, which tells us that, we could have factored this equation, but again, we're just practicing using the quadratic formula. So if I can factor, I always like to factor because you can see it's a lot faster than using your quadratic formula, but that's okay. So we have our solutions then. U equals 2 and u is equal to 1/2. But remember, we used substitution and said that u was the cosine of x, or let cosine of x equal u. So now we need to substitute that back in. So the cosine of x is equal to 2, and for this one, the cosine of x equals 1/2. So remembering our chart, when we get values that are above 1 or below -1, remember we said there's no solutions because we can't find an angle that gives us a trig ratio above those values. So for this one, this is no solution. But over here, when cosine of x is equal to 1/2, we have two solutions, and we can use our unit circle values to help us because we know that where do we get 1/2 for our cosine? Here at pi over 3 and down here as well. So, but remember, since this is cosine, we can write our answer as x is equal to plus or minus the cosine inverse of 1/2 plus 2 pi n. So x is equal to plus or minus pi over 3 plus 2 pi n gives us our solutions. But of course, if instead you were to write your answer as x equals pi over 3 plus 2 pi n, and x is equal to 5 pi over 3 plus 2 pi n. That's also correct. It doesn't really matter. So since it's on your unit circle, if you want to use that instead of writing the plus or minus, it's fine. Just because of we're solving, I like to do the plus or minus in front. I think it's easier, so you don't have to think about another value on your unit circle in case you don't remember those values. That's why I just usually write that, and it follows the rules of how to solve. So let's go ahead and look at problem number 6, and this will be the last one we do. We'll do number 8 together in class. So for number 6, when you are solving these, just make a note that you don't want to divide out your trig function. The reason you don't want to divide it out, because remember, when you divide by something with a variable, you are introducing solutions that may not work, or you might also miss solutions, because remember, we can't divide by things that are equal to 0. So whenever you're solving, you don't want to divide your trig function, so don't do that. Instead, I would set it equal to 0 and see if you can use your identities to help. So if I set this equal to 0, I'm going to subtract the cosine x on this side. So when I do that, I get cosine x sine squared x minus cosine x is equal to 0. And then I could think about using my trig identities. I know that sine squared x is 1 minus cosine squared, and that would give me all cosine, or I could also do algebra and factor out a cosine to get the cosine and sine so it's by itself. So I'm going to go ahead and do that. So I get cosine x times sine squared x minus 1 because I factored out the cosine. And when I factor it out, then I can write the cosine of x equals 0 and sine squared x minus 1 equals 0. So my first solution I have is where the cosine is equal to 0. So 0 is in between -1 and 1, so that means we have two solutions plus 2 pi n. So where does cosine hit 0? At pi over 2 and 3 pi over 2, or because it's the cosine inverse, remember we can just write plus or minus pi over 2 plus 2 pi n. If you want to write pi over 2 and 3 pi over 2 plus 2 pi n, that's fine as well. It's the same thing. And then here we get the sine of square root of x is equal to 1. How do I get rid of something with a square root? Well, remember, to get rid of a square, we take the square root, is what I meant to say. And remember, when we take the square root, we have plus or minus our answer. So the sine of x equals plus or minus the square root of 1. So we get the sine of x equals 1 and the sine of x equals -1. So 1 and -1 only have, remember, one solution in our unit circle. So here we get x is equal to pi over 2 plus 2 pi n, and x is equal to -1 would give us negative pi over 2 plus 2 pi n. And again, if you want to write x equals 3 pi over 2 plus 2 pi n, that's fine. It's the same thing. But notice these are the same answers as what we have right here, so we could just don't have to write them multiple times. You can just write it once. It's fine. And remember, I said you could also use your Pythagorean identities. So if I redo this problem, cosine x times sine squared x minus cosine x, remember the Pythagorean identity right here. Sine squared x plus cosine squared x equals 1. So that means 1 minus cosine squared x is equal to sine squared x. So if we take that out and replace it in our equation, and then distribute, we get cosine x minus cosine cubed x, because when you multiply something in the same base, you add the exponents, minus cosine x equals 0. These would cancel out to give you negative cosine cubed x equals 0. Divide by the -1 and we get cosine cubed x equals 0. How do I get rid of something that's a cube? We take the cube root. So the cosine x equals the cube root of 0. You don't need a plus or minus when you're taking an odd power root. So, or getting rid of odd power, I should say. So whereas the cosine of x equals 0, we said already at plus or minus pi over 2 plus 2 pi n. So again, you could use algebra or identities and some of these to solve using the quadratic formula. So as you can see, it uses a lot of information we've already learned, the unit circle, values, how to use sine or cosine or tangent inverses, and then that's why it gets a lot more complicated. So like I said, we'll go ahead and take a look at question number 8 in class together, but for the rest of these, make sure that you are practicing them and make sure you know your unit circle values and the rules for how to solve, because it does get tricky with these problems once you start introducing having to factor or use a quadratic formula or using your identities.